All right, last topic in this chapter, we're looking at solving rational inequalities. Okay, somewhat similar to what we did yesterday when we eventually get to our answers, but before we get to where we can get our answers, it's slightly different. But you guys should be able to handle it. We're going to go over 3 examples, and you'll have 5 problems for homework. Okay, because they're a little bit more time consuming than yesterday's problem. So, what do you think we're talking about with rational inequalities? Fractions and with a less than or equal to sign. Good. Okay, so this is an example of what we need to work with. So 4 over x minus 6 plus 2 over x plus 1 greater than or equal to 0. So, thoughts on this? What do we need to do? Common denominator. Now, the other day when we found the common denominator when we were solving rational equations, what did we do with the common denominator? We multiplied by it to cancel out the denominator. You cannot do that if you're dealing with an inequality. If you're dealing with an inequality, the denominators have to stay there. So my common denominator is going to be what? X minus 6 and x plus 1. X minus 6 and x plus 1 is correct. So that means I need to multiply 4 by something. What is it I need to multiply 4 by? X plus 1. What's an easy way to figure out what you need to multiply by? Right, what's not already in the denominator? I've already got x minus 6. I don't have the x plus 1, so that's what I need to multiply by. So that means the 2 needs to be multiplied by x minus 6. Good. Okay, now that we have the same denominator, we can put them together. So that gives me 4x plus 4 plus 2x minus 12. Like terms gives me 6x and negative 8, or minus 8. And at this point, we're going to be able to see what we need to go to the number line with. Kristen?
Do we have to keep it, do we have to keep putting the x minus 6 and the x plus 1 underneath it?
They have to stay there, yes.
Okay.
All right. At this point, we're ready to go to the number line. What do you think needs to go on the number line? Negative what? Negative 1, negative 6 are correct. And one more thing. What else needs to go? 8 over 6, which reduces to 4/3. So I need 4/3, I need 6, and I need negative 1. Let me put those on the number line, and then we'll talk about them. Okay, what are 6 and negative 1? What are they? They're not zeros. Which means they are what? What did we learn earlier this week? What did we learn that helped us? We found these to help us graph. They are asymptotes. Okay? So we need to put the asymptotes on the number line. What does that mean 4/3 is? It's a 0. Why is it a 0? Because we get zeros from the top, we get asymptotes from the denominator. So when you're doing rational inequalities, you need the zeros and the asymptotes on your number line. All right? So now we want to go through on each section, and we want to plug into this to see whether or not we get positives or negatives. So, something to the left of negative 1. Negative 2. If I plug negative 2 into the top, does that make my top negative or positive? Looks like it makes it negative to me. Because that would make it negative 12 and a negative 8, and a negative gives me a negative. On the bottom, negative 2 right here on the x minus 6. Makes that a negative as well. Negative 2 right here. And negative as well. So if I have 3 negatives, that means that section is negative. So this section is negative. Okay, what about between negative 1 and 4/3? Oh, question.
How did you do what you just did?
How did I do what I just did? Okay, negative 2 is over here, right? So I put negative 2 in the top. So negative 2 times 6 is negative 12. Negative 12 and negative 8 produces a negative. So I let myself know that the top one is negative. Did the same thing here. Negative 2 and negative 6 means that this right here is negative, so that is negative. Negative 2 right here also makes a negative. And if I have...
You can't just put it in the bottom once, you do it twice.
You got to do it twice. That is correct. And then the combination of these three signs produce a negative.
What if you had one positive?
What if I had one positive? If I had two negatives and one positive, it would have been positives. And that'll happen here in a second. All right, between negative 1 and 4/3. 0. So if I plug 0 into the numerator, negative. If I plug 0 into the first one on the bottom, negative. If I plug 0 into the second one on the bottom, positive. So what's the combination of two negatives and a positive make? It makes a positive. Okay, between 4/3 and 6. 2. 2 in the top. Positive. 2 on the bottom left. Negative. 2 on the bottom right. Positive. So the combination of those three is negative. Okay, then something to the right of 6. 7. 7 in the top. Positive, bottom left, and bottom right. So that means that section is positive. Okay? That's a good question. I know for sure on the polynomials that they're going to alternate, but on the rational stuff, I'm not 100% sure. So I can't guarantee it. As soon as I can figure out one way or the other, I'll let you know. But as of right now, you're better off plugging in. Alright, so it says we want greater than 0. So which part do we want? We want the positives. So I'm going to have negative 1 less than x less than 4/3 or 6 less than x. And there's my solution. Okay. Same approach as yesterday once you get to the number line. But getting to the number line is a little bit different than what we did yesterday. Questions on that before we move to the second one? Alright, next one. 3x minus 2 over x plus 3 is less than 6. X minus 2 over x plus 3 is less than 6. Alright, thoughts on what to do to this one? Move the 6 over, good. So 3x minus 2 over x plus 3, and then minus 6. Alright, now what I want to do? Common denominator. It's obviously going to be what? So do I need to do anything to the 3x minus 2? No, because it already has the denominator. Okay, but I need to multiply 6 by x plus 3. So 3x minus 2, make sure you distribute the negative 6 to both of those. So negative 6x minus 18. Distribution issues are a big part of why you guys would miss a problem like this. You'd probably give me a positive 18 there instead of a negative 18. So make sure you pay attention when you're distributing. Like terms together gives me a negative 3x and a negative 20 over x plus 3. Once I get here, I'm ready to go to the number line. What needs to be on the number line? Negative 3 and negative 20 over 3. Which one of those needs to be on the left? Negative 20 over 3 needs to be on the left. All right, so what's the number on the left of negative 20 over 3? Negative 7, negative 7. So negative 7 on the top, positive or negative? Positive, right? Because this turns into a positive 21 and a 20. So I'm positive on the top, negative 7 on the bottom. Negative on the bottom, so that combination means that section is negative. Okay, in the middle of those two, what's the number? Negative, how about negative 4? Let's do negative 4. So negative 4 on the top, that makes that 12 minus 20, which is a negative. Negative 4 on the bottom also produces a negative, which means I have a positive. Then on the right side, we should definitely pick 0. 0 on the top is negative, 0 on the bottom is positive, which means that section is negative. Okay, and which section is it that we want? We want the negative section. So I have x is less than negative 20 over 3, or negative 3 is less than x. There's my answer. Christian.
What number did you use to get the positives and the negatives, and like to determine whether it's
Over here, I use negative 7. In the middle, I use negative 4. And over here, I use 0.
So we can just use any of the numbers that are in between that
Correct.
section.
Correct. So there's my solution. Any question on that one? So what does this number line tell me about my graph? What do I know about my graph on the outsides? Where is it located? Where is it located?
Below the x-axis.
It's below the x-axis, and in between those two, it's located above the x-axis. So this one, most of the graph is below the x-axis. A small portion is above. All right, last one. All right, 4x plus 1 times x minus 2 over x plus 3 times x minus 1 over, or less than or equal to 4.
You should just multiply out the top.
On the left side,
No, well, I guess you're dividing.
let's move the 4 over. Alright, so I'll move the 4 over. What do we want to do next, Blake?
Find a common number.
And what would that be?
X plus 3 and x minus 1.
Very good. Okay, do I need to do anything to the left one? No, it stays the same because it already has the common denominator. But on the right side, what happens? I need both, right? So it gives me that. So now what needs to be done to my numerator? I don't factor it. I need to multiply it out. Is what I need to do. So on the left side, I need to multiply this out, which gives me 4x squared minus 8x plus x minus 2. On the right side, x squared minus x plus 3x minus 3. Distribute this negative 4 right here. Put these two together. So that would be negative 7x minus 2. And put these two together right there, which is 2x. So negative 4x squared minus 8x plus 12. Like terms together, so what happens to the 4x squareds?
Cancel.
Those cancel out. I've got negative 7x and negative 8x, which is negative 15x. I've got negative 2 and a positive 12, which is 10. Let's see. So now we're in a position where we can find what we need to go to the number line. So what's going to go to the number line?
Negative 3,
Negative 3, positive
positive 2,
1, and what was the other one?
positive 2/3.
2/3 is correct. Very good. So negative 3, 2/3, and 1. So left of negative 3, negative 4. If I plug negative 4 into the top, positive. Negative 4 into the bottom left, negative. Negative 4 into the bottom right. So those two are negative, so the combination of the 3 is a positive. Between negative 3 and 2/3, 0. 0 on the top is positive. 0 bottom left is positive. 0 bottom right is negative. So positive there. So the combination of those 3 is a negative. Okay, between 2/3 and 1. 3/4. And actually, what is 2/3 of the decimal? 0.66. So what's a number just to the right of 0.66 that we might want to use?
0.7.
0.7. So let's do that. So let's do negative 15 times 0.7, and that gives me negative 10.5. So what does that make the top? Negative. On the bottom, a negative 0.7 on the bottom left is a positive, and a negative 0.7 on the bottom, not negative, sorry. A 0.7 on the bottom right is negative. So I got a positive and a negative down there. So the combination is positive. Okay, then to the right of 1, let's pick 2. 2 on the top. Negative. 2 on the bottom left. Positive. 2 on the bottom right. So that means that section is negative. Alright, so what does this problem want? Positives or the negatives?
Negative.
It wants the negatives.
So between negative 3, 2/3, and, or you could say 4, 2, x has to be greater than 1.
However, there's something slightly wrong about my answer. I'll be really impressed if somebody can figure out what's wrong with the answer. Christian.
Wait. What are you repeating if you're saying that?
Outstanding. This right here cannot be equal to, and this right here cannot be equal to either. Because what are negative 3 and 1?
0.
They are asymptotes. And you cannot equal something that's an asymptote. So if I have an asymptote, make sure whenever you write your inequality at the end, whenever you write your solution, that you do not have equal to on those. That's an outstanding catch. Very nice. Okay, so if we're solving rational inequalities, what's the first thing we want to do? Get everything on the same side. Then a common denominator. Okay, and then work it out. Once I get it worked out, what are we going to put on the number line? Asymptotes and zeros, and then I just figure out what's positive and what's negative, and then answer the solution. Brief.
On your positive and negatives, are you gonna ever have where you have like 2 positives next to each other as negatives? Or
That's a good question. I need to go find a way to get to something like that and then show it to you, because I think you can go positive. I don't think that. Sure. I think you did something. Should be a negative. All right, so that's solving rational inequalities. Here is your assignment. Okay, there are 5 questions. 18 to 26 even.